The objective of this presentation is to help us understand what is an SQL. We can simply say SQL is structured query language, but it's very important to understand how SQL came into existence. To do that, I will be following this below agenda. I will define the acronyms first. Then I will talk about birth of relational data model. Then what happened after 1970, the birth of relational data model. And what are the two relational prototypes and how SQL came into existence. And finally, I'll conclude. Let's get going. SQL, Structured English Query Language. SQL, Structured Query Language. In 1977, because of some trademark issues from UK, SQL was shortened to SQL. Sometimes people call it as a SQL or SQL. Both are same, but I prefer to use SQL rather than SQL. Before I explain further on SQL, let me first take you back to 1970. What happened in 1970? The birth of relational data model. E.F.Codd, in short E.F.Codd, published a relational data model paper. It was the revolutionary paper in database industry. Even after 40 plus years, our data models are still relational. The most preferred data model is still relational model. Here is the E.F.Codd paper. You can read it from browser, through a browser. If you read this, his research problem was very simple. He highlighted lack of data independence in prior data models. What were those prior data models? You have a graph model, you have a network model, you have hierarchical or simple file-based data models. Now, what is the meaning of this data independence? For example, if I build a data model using, let's say, network, any changes to the data model, for example, if I'm adding a new field, that used to require some significant changes from application program as well. So the changes on the data model side were not hidden from the front-end application. That was the research problem he took. And the solution he suggested was relational data model. And in relational data model, there is a form of tables, tuples, attributes, you have constraints, you have normalized data. That's altogether a different subject. Moving on, after E.F.Codd proposed his breakthrough relational model paper, the industry is kind of divided. The researchers team is kind of divided into two separate teams, or rather I would say two sides. They took two different sides. On one side, E.F.Codd and other researchers who appreciated the merits of relational model. On the other side, members of COBOL or Codicil who recently wrote a proposal for network-based system. The main criticism from this group on this side was that relational model is too mathematical. The main criticism is relational model is too mathematical. However, these guys never gave up. Supporters of relational model have started implementing various prototypes of relational model. So from 1970, after the birth of this relational paper, this group started implementing some prototypes. Because if you actually read this Codd's paper, this is more on a theoretical side. He spoke things at a very high level. He never talked about anything on the implementation side. So the successive papers started implementing that model, relational model. two widely used prototypes that came out of the 1970s paper are System R and Ingres. Now the System R project is the effort of 15 plus researchers, and they built this System R project as a real implementation of relational model of E.F.Codd between this 1974 and 78. So if you look at the System R, gave actually birth to the following major database vendors. Larry started his own company and implemented his own System R implementation and released Oracle in 1979. IBM SQL data system in 1981. Their database 2 is pretty much the DB2, their own IBM's own database system in 1983. On the other side, there was another group who is putting a lot of effort on Ingres, and it was led by none other than Michael Stonebreaker, a man who needs no introduction in a computer world. Along with students in a UCB university, he started developing this prototype. And this prototype gave birth to these following database models, database systems. Sybase, of course, from then Microsoft SQL Server. Nonstop SQL, it's from HP, and a Postgres. If you see the Gres here, Postgres, they took the name from Ingres itself. What are we talking so far? I quickly introduced you to what is SQL and what is SQL, the acronyms. I told you it all started with 1970s research paper. Then after 1970, the industry is kind of divided into two separate sides. And one side is started implementing relational prototype, System R and Ingres. All the databases you see currently, the relational databases, they are from these two. They are somehow or some way or the other way related to these two prototypes. Now, where is the SQL fitting in this whole structure? If you go back and read this Codd's 1970s paper, he spoke about, and of course his successive papers, he spoke about two relational query languages, but he never implemented them. So one is relational algebra, which is pretty much a relational algebra operators. Like this is how we should implement join between two tables, and phi is a symbol to represent the projection. This is most of a symbols operators. And the relational calculus, which is also known as data sublanguage alpha. So it was left pretty much to further researchers to implement their own relational calculus. Now what these two subsystems, prototype systems, System R and Ingres, did was they implemented their own relational calculus. Relational calculus that uses these operators to fetch the data from tables and play around the data. And Ingres named that relational calculus or data sublanguage alpha as QUEL, query language. And System R named it as a SQL, structured English query language. Of course, like I already told in my previous slide, which was renamed to SQL because of some trademark issues from UK. Now, if you see, there are two different data prototypes, System R on one side, Ingres on other side. System R using SQL, Ingres using QUEL. Now, within just a few years, SQL won the battle. SQL won the battle. Even database systems which were implemented on QUEL, they even converted into SQL. That's how the birth of SQL became dominant. The birth of SQL happened in a System R project. If somebody asks me now, what is an SQL? It's very simple to say SQL is a standard language that we use to talk to relational databases. If this is my relational database, SQL is a standard, which is a language which has various commands like any other language, which helps me to talk to the database and which helps me to query the data, which helps me to get the data out of it, which helps me to update it, right? So if I quickly go back to my agenda, so we spoke about acronyms, we spoke about birth of relational data model, what happened after the system R Ingres, and then how SQL came into picture. I know this is a lot of terminology. If you are not from a database background, it's tough to digest. To be honest, if you are non-technical, you don't really have to understand all these internals. But simply when somebody says, what is an SQL? Somebody asks what is an SQL? It's a structured query language. It's a standard using which relational databases talk to their users or applications. I would quote one more example. You see, I'm talking a language called English, but my mother tongue is different. You might talk English with your clients, but your mother tongue might be different. But when we both talk to each other, we talk in a common language so that we both understand, right? Let's say if you speak in Chinese and if I speak in English, it makes no sense. We need a translator, right? If I speak in Hindi, that's from India, and you are trying to speak in Chinese, that's from China, it's not going to work out. We have to speak in a common language. Similarly, for databases to understand the applications, the common language is SQL. That is a de facto standard of communication. With that, I conclude this presentation. Thank you for taking time and feel free to leave comments in the comment section. Looking forward to talk to you in the next presentation.